Okay, hi everyone. I hope this video finds you well. So today we are going to talk about inheritance. We are also going to cover the nested classes or an introduction to nested classes. We are also going to cover compositions, polymorphism, and finally we're going to cover method overriding. So before we start, pause the video and create a new project and call it Sandbox 3. I'm going to create that in front of you right now. So I'm going to do file new Java project, and I'm going to call it Sandbox 03. So I'm going to finish that. Then create a class. Now this class is going to be called demo or your main, whatever you want to call it. So I'm going to call that my demo class, and I'm going to add main to it. If you want, you can generate comments or make the Eclipse generating comments for you. So finish. Now I have this ready, and we are going to start our lecture. So you can keep these projects we are creating throughout the quarter because you may need them when you review for when you do a review for the exam or something you want to remember. Okay, so today we are going to talk about inheritance and methods overriding, compositions, and all these concepts. So to talk about inheritance, you should know that inheritance is one of the main concepts of object-oriented programming, and basically it is when an object is based on another object. Now we call that prototypal inheritance, or a class is based on another class. This is class-based inheritance. Those objects are going to be based on each other, depending on each other, using the same implementation. It's like inheriting from an object or a class. Doing that, specifying implementation to maintain the same behavior. So generally, you may get asked this in an interview or something similar. Inheritance represents what relationship? And you should know that inheritance represents the is a relationship. It's also called a parent-child relationship. Now, why do we need inheritance? Because of the code reuse. Code reuse usually is the most important benefit of inheritance, because a subclass, and you're going to know what a subclass in a minute, inherits. We use the word inherits because it's going to take over everything of the parent class. Inherits variables, methods, and all things of the superclass or the parent class. So basically, inheritance represents a new class wants to offer the same interface. Now, when we say interface, we talk about services, we talk about functions that the superclass, class 2, provides. But also may want to add a new services. Now, why do we say may want to add? Because it doesn't make any sense to say this is a subclass of this one by just taking over everything of this one. Then why creating another class in the first place? Why not using this one? So let me give you something. Here's an example. This person breathe and eat. Breathes and eats. So a student can also breathe and can eat. So we know if the functionalities of a person would be eating and breathing, then a student can do those things. That means a student is a person. But also a student can do something else. So you can think about it as a student is specialized in doing another thing over a regular human being, which is studying. Studying. So class 1 is said to inherit, here is class 1, is said to inherit from class 2. That means class 1 is a class 2. In this example, you just get rid of these. In this example, a student is a person. Now, the opposite is not true. Now, you cannot say a person is a student because not every person is a student. A student is definitely a person. But a person is not a student. But because you can also have instructor, and an instructor is a person. You can have a doctor, and a doctor is a person. You can have engineer is a person. So we can also say a car is a vehicle, right? So now we know a student is a person. A student is a person because a student breathes, eats, but also studies. Now we have C++ student, Java student. Pretty much they inherit everything from a student because they can breathe, they can eat, they can study, but also they kind of specialize or add a new feature, which is writing a code. Writing a code means expanding the capabilities of the parent class. So now we can say a CPP or a Java student is a student, and a student is a person. Now, with this relationship, we can eventually say a C++ or Java student is a person. And that is going to be true. That is going to be true. But now if we have to write everything from scratch, like we have to rewrite breathe, we have to rewrite eat, and we write a new study. Is it the way this works? No. What we do is, since we said a student inherits everything from a person, then you don't have to write anything down. It's going to be included. These are included with the relationship. Included with the relationship. So, what do I have to write then? You just to make sure that you extended. Now, when I say extended, I mean you defined the relationship. We defined the inheritance relationship with the keyword extend. Extends. So, that student extends person, which means takes everything from person and extends. Remember, expanding, adding a new feature. Now, whether it's one feature or multiple features. Same thing in here. C++ student or Java student, extending student, which means takes everything from a student, including the new features added, plus adding new features in the CPP student. Okay, here's another example. Another example would be shape. Shape has a location, a color, has a property called whether it's filled or not, and has two functions or three main functions, draw and setters and getters. Draw would draw the shape, and get would get the values of these variables. Set would set these values. Would set these values of these properties. Now, we can say a circle is a shape. If we're saying a circle is a shape, then it has to extend. It has to extend shape. So it takes over everything from the shape. As you can see, all blue are inherited. and extends that with the radius, adding a radius because a circle needs a radius property. Same thing with a square. You inherit everything from the shape and you add height and width, which specify what shape it is, a square. Here's the names used with the inheritance. Now, we have a base class and a derived class. The base class and the derived class. We can also use a superclass and a subclass. We can also use a parent class and a child class. A parent class and a child class. So a base, super, parent, they're all the same. Derived, sub, child, they're all the same. Those are inheriting from this. Okay, so here's an example of an inheritance. We have a point, and we have a circle. Now we can say a circle is extending point, which means a circle is inheriting everything from point and adding radius. So the constructor of point would be taking x and y. The constructor of the circle is going to provide the x, y, and the radius. So if we have point P equal new point, this is talking about point. Talking about this one, right? So here is point. Now, if we are talking about circle C equal new circle, we know a circle is a point. A circle is a point, right? So a circle from the inside is a point, but adding extra things, right? Adding extra things. So, for example, if we have point having get x, get y, set x, set y, and circle is inheriting everything from point and adding those. Those are additions. Those are extra features circle provide over point. Now, if we have point P equal new point, then we are talking about point. If I do P dot, then what functions I could use with P? You guessed it right. I can only use those functions. Get x, get y, set x, and set y. But if I have circle C equal new circle and I give it the appropriate x, y, and r, the radius, then when I do C dot, what functions I can use? What functions I can use with C? Also correct. I can use all these because circle inherits from point, which means that it can use everything from point, takes over those, right? And it can use the new features. So can use C, can use all points and circles functions, all these. Now, if we have a function, in here, that function takes point variable, takes point object. It's named foo, so we are taking, this function takes a point object. Now, if I do foo P, and P, as you know, is of type point, is that legal? Now the question is, why not? Yes, it takes point and that matches, right? This is a match. So yes, it is legal, of course. But if you're saying, oh, foo, it takes a, does it take a C? So can we try and give it a C? Now, remember C is a circle. C is a circle, and this takes point. So is there a conflict? We are providing a C of type circle, but what we need is a point. Is there a conflict? Now the answer to that is no, there is no conflict. C has inherited all the abilities of points, so C is a point. Since there is a relationship, we have is a relationship, then C is a point, then it is accepted. It is accepted. So this is called upcasting. Upcasting means converting from a subclass type to a superclass type, because this is enforcing the idea of the is a relationship. Is a relationship. This is upcasting. I upcasted C to be a point and passed it to the foo function. So let's go over the concepts. Now we know if circle is inheriting from point, then C is a point. C of circle is a point. And C is also a circle, because C is a point, which means I can use everything from point. But I also, when I say it's a circle, because I can use those extra features, right? Those extra features. So, I mean, like this is X and Y. Here I can find radius. This radius. Okay, so now we have P and C, P of point, C of circle, and I have now bar function. Now bar function takes C, circle, takes a circle. Now, can I say bar and I provide P? I pass P. Remember, circle is a point, not the opposite. Not the opposite. So can I say P is a circle? Definitely not. Then is this legal? Now, no. Point is the parent, so it does not have anything to do with the circle, except that point is parent of circle. But actually point doesn't know. Point doesn't know she is a parent of which classes. Or sort of saying. So point does not have the same abilities circle provides, because I can ask you something. If you have in this implementation one of these statements, circle let me just write in here. Circle dot radius. Or circle dot sit radius. But you're passing a point. A point does not have radius. Right? So that won't work. This is not going to work. If it's a circle, then yes. So just remember, P is just a point. P is just a point. Circle is said to be both, because it inherits everything from point and it is a circle, right? So what kind of inheritance we have? In Java, we have 3 types of inheritance. In other languages like C++, we have 5. So the 3 types of inheritance Java provides are the following. The single inheritance, like a single class inheriting from a single class. A multi-level inheritance, a class inheriting from this class, and this class happen to be inheriting from this class. And hierarchical. Now the hierarchical is 2 classes inheriting from the same class. Two classes inheriting from the same class. The other two that are not supported by Java are the multiple inheritance and hybrid inheritance. And I'm not going to talk about those because I'm not going to confuse you. If you are interested in knowing about all these, you can Google them. So here's an extra example that would show you what to expect from your inheritance classes. So if I have NPC, an NPC is a non-player character. This is any character in a game which is not controlled by the player. So if you're playing a battlefield, you see other soldiers in the battleground, but if you're not controlling this soldier, then it's a non-player character. Here is human inherits from NPC and a monster inherits from NPC. Now, a human could be a warrior, wizard, or cleric. A goblin or CC print and dragon could be of monsters. So human inherits everything from NPC and monster because NPC could be either a human or a monster. And a monster is going to have its own subcategories, and same thing with the human NPCs. So in inheritance, you don't need to recreate or redefine all the functionalities of the parent class, right? Because as I said, you don't have to rewrite them. They are just being inherited by extending the parent class. So by inheriting from a base class or a parent class, I get all its built-in functionality. I can also extend the class by adding the things the things I wanted. The methods and the data items I have access to depend on the access modifiers this variable or a method has. I may still have access to private methods and data indirectly in the same way client does. Now we are going to see how I can do that. I can also get a class functionality by adding it as a data member to my class. And this is what we call composition. Composition is using another object as a data member, as a member data of my class. It's like a variable. I'm going also to show you that today. So let's talk about the things inherited and what each of these classes would inherit. So if I have NPC class with all these fields, properties, and those functions, this is the constructor, so we don't have to worry about it. What we need is the other functionalities this provides. So those two functions are going to be inherited, could be used in all subclasses. Now those are direct subclasses, but also those are indirect subclasses. So you can use those two functions in all subclasses. Took from a human. So a human, a monster, and all these subcategories, they can attack and they can move. But only a human can talk. And everything inheriting from a human can talk. Like a cleric, a warrior can talk, a wizard can talk. Now a monster can attack, can move, but also can terrorize. Extending the functionalities, right? Adding a new feature. Terrorizing. And all these subcategories of the monster can terrorize. So you have to know something. The parent class of all the classes in the whole world is the object class. So class object, you can think of it as the root of all the classes in the whole world. So every class has the object class as a superclass without you doing the extension. You don't have to say, okay, when I create a class, X extends. You don't have to do that. When you do class X and you open the bracket, you're now extending object class without you knowing. Okay, so all objects, including arrays, implement the methods of this class. So here's some functions, some methods the object class provide. You have seen some of them before. You may have seen toString, one of the famous functions, equals. Remember when you used strings in CS141 and Java 1? You used equals with a string. That was using the equals from object with something added to it, which we are going to call a method overriding in the next few slides. So let's try inheritance for now. Let's just focus on inheritance and try it for now. So we have subclass. We have a base class, We have a base class. And the base class is bicycle. And this bicycle has 3 properties, 3 variables: cadence, gear, and speed. You can set the cadence, the speed, and the gear using the constructor. And you can set cadence using another function. We have a function that sets the cadence, function sets the gear, and you can apply the brake or speed up, which is going to either increment or decrement the speed. And we are going now to use the extends keyword. Now the extends keyword means that you can use all the features from the superclass. So basically you're creating a subclass. This is how you tell the compiler that I'm creating a subclass of this class, the one I'm extending. And you can only extend one class in Java. So one class in Java can be extended. In other languages like C++, you can inherit from more than one. But in Java, you can only extend one class. And this is important. This is going to be on your test. So the super keyword. This is another keyword in Java. That is a reference variable, which means that you can refer to the immediate parent class object or variable or a method, depending on what you are using super for. So whenever you create an instance of a subclass, an instance of the parent class is already created. Remember this? Let me just take you to this. This is what we want. Nope, this. Okay, remember this? When you created C, because circle is extending point, when you created C, internally something of point is created. An object of point is created. Or you can think of it like this for now. Okay, let's go back to our slide. Okay, so how would you use the super keyword? You can use the super keyword in many aspects. The first one would be super can be used to refer to the immediate parent class instance variable. If you have instance variable. It's like if you have a dog class if you have a dog class inheriting from animal class, this is the parent class, then you can do super.color because color is defined in the animal class. Here is color. Also, super can be used, this should be 2. Super can be used to invoke immediate parent class method. For example, if you're defining a work method in dog class, if you want to define work as first the dog is first eating, then barking, then you can say, okay, I know the eat method is in the animal class. So how do I refer to it? You can do that using the super keyword. You can do super.eat, which calls the eat method from the animal class. Then you can have your bark method, the one you should be implemented before. Super also can be used to invoke the immediate parent class instructor. So dog constructor, the dog class constructor, calls the first line in the dog constructor must be the super of the parent class. Now, if you haven't called it, if you haven't added this, the compiler is adding this for you. The compiler is going to add this for you. Because this is how the relationship is created between the dog and the animal classes. So right now, let us use the word extends and the word super. So as I said, now you're going to specify what kind of bicycle you have. You want this bicycle to be like any bicycle, uses the cadence, the gear, and the speed. Set the cadence, set the gear, and changing the speed. But also, you want to say, okay, but I mean, this bicycle is going to be specific or special. How do I add a new feature? You're adding seat height. Which is going to differentiate the regular bicycle from the mountain bike bicycle. So we're going to try different things, and I'm going to explain things while I'm working on Eclipse of how this is going to be done. So here is the demo, and I'm going to create another class. Now, if you're going to be creating classes depending on the certain package, you can call that. I'm going to create 2 things in one. Okay, I can name that bicycle. Let me just go here. I want to copy the code. First, take the name. Here is bicycle. And you can define what package you want. Because see, we are in CS143 course. I'm going to use my name also, because you should be using your username. My username is Ilready. This is not the one with the main function, so I'm just going to hit finish. Now, as you can see, demo is not in the same package. You can move it to be in this package and delete this one, or you can just leave it the way it is, depending on why you're going to do that. So let's copy this code and put it in here. Here it is. Now I defined 3 variables, and I use the constructor to set the 3. If I needed to change cadence, I can do that. If you wanted to change the gear, you can do that. If you wanted to change the speed, you can also do that. Okay, so right now we are creating mountain bike, creating a new, in this package I'm creating mountain bike in the same package. So finish, and I'm going to copy this code. Now mountain bike, let me just format that, Control A, Control Shift F, that formats it. And now you can see mountain bike is extending bicycle, which means it takes over everything in here, everything, like it takes over those. You can access everything from these, you can access these functions, you can use them, and you can do pretty much everything bicycle does. So here it is. I'm just adding one extra function because I added seat height. I passed the three variables, the 3 values needed for the 3 variables here, right? I passed them, and I used super. It's like calling the object, creating an object of bicycle and passing those values to it: start height, start speed, and start gear. Then this is needed because this is needed to set the seat height. Also, you can use the seat height from here. Now, in the demo, let me just, because this is public and this is public, I can access this from anywhere. So I hit save in here, okay. Then I would do mountain bike equal mountain bike equal new mountain bike, and I should pass seat height, let's say 4, and you would pass start cadence, let's say 12, and you would pass the start speed, let's say 75, and the start gear, that was 1. So now to see what mountain bike has access to, we would call this mountain bike, this variable, right? Now if you do dot, that will give you access to cadence, gear, seat height, and speed. But wait a second, speed, gear, cadence, aren't those implemented in here? Yes, but remember that mountain bike extends bicycle, then it takes over everything from bicycle. So yes, you have access to those. You can have access to those things. Here are those. Now let me just do this. Private and save. Control S. Save. Now let's do that again. Dot. Oh, that disappeared. Why? Because you cannot inherit the private things. You cannot inherit private things. But wait a second. How do I use it if I don't inherit it? Now you can use it using the set cadence. Now I can do set cadence, right? And I can do, the cadence now is 145, whatever. Now if I printed cadence, I'm going to add a new function here. That is print function. Or let me just teach you something. I'm going to override the toString. Remember, as we said, this class is extending object without we explicitly saying that. Okay, I'm going to teach you how to extend, how to override. And overriding a function is using the same signature of both functions in two different classes, in the subclass and the parent class. The function in the subclass is being overriding this. Or let me just source generate to string, and this is going to generate the string to print cadence, gear, and speed. Okay, let's do that. Now this is added in here. Let me just take it. I like to have it always at the very end. Let me just take it in here. It doesn't matter where you have it, but I always like to have it at the very end. It's more tidy code. Okay, so here is the toString. This is returning a string. This is returning a string. So if I comment that, I'm going to show you something. I'm going to show you something. Let me just comment that and try to print this. System out println, and I'm going to print mountain bike. What do you think being printed? What is mountain bike? Mountain bike is my object, right? Let's see what's going to be printed. Let's run this. Let me just run it from here because I was running something for. Okay, that printed the package I'm in and where that class is located and the hash code of that class. The hash code of that class, right? So is this what I need? Is this what I need? No. What I need is to see what are those things. What are those things? Let me just uncomment that, run that again. Oh, that printed, even though I printed mountain bike, this is printing bicycle. Then the cadence is the 145. So I used cadence in here. I used cadence, right? Cadence was the second. So I used cadence to be 12. And then I changed it. So I still have access. Even though it's private, yes, I still have access to it because I'm inheriting that, but I cannot directly change it. I cannot directly change it or read it, but I can indirectly using setCadence. See how cool is this? Now, let me just prove to you that we actually changed it to 145. So printing that, this is printing cadence 12. This is cadence, right? This is cadence. Now, let me just uncomment that, print it. Now this prints cadence to be 45. This sets cadence to 45. Okay, now, but I'm printing mountain bike. I'm printing mountain bike. I do not want to see bicycle. So you can either you yourself overriding public, and if you're overriding a function, then you should copy the whole function signature and you should change things in here. Let me just change things. So if we want to, let's keep this and we say, okay, this is mountain bike and the cadence is what is cadence? Now the thing is, we do not have access to cadence. If we wanted to print cadence in mountain bike, we would never be able to do that. Why? Because it should be here a getter for something private, but you have only setters. So what we are going to do is, here's we have set cadence. We are going to have public method, and it's called this is going to return to us int, and it's called get cadence, right? And this is returning cadence. This is returning cadence. Let's save that so the compiler can see it and that takes effect. So now instead of saying cadence, I can say get cadence, or Oh, this is demo. Oh, I'm putting that in demo. That should be in mountain bike in here. So even in here, if you said cadence, you would not get cadence, but I can say get cadence. See? Now I will get the value. I will get the value. I will add to this speed equals speed, and I will add this. So plus change that to seat height, and this, let me just remove this. Seat height. Now let me see, I have this extra. Everything is good. Now let's print mountain bike. Let's see, do we still get bicycle? No. We got mountain bike, we get the cadence, the gear, the speed for the mountain bike, and we got speed height. Seat height. We got seat height. So this is how we do things in here. And if you want to change anything in here to be private, then you should provide setter and getter for it, not just a setter, unless you don't want anyone to read it except the methods in the same class. Okay. So what if I removed this gear? What if I removed this public, and now public is what we call default. Default means it's not public, and it's not private, and it's not protected. We are going to see those. Default means it's a package private. So anyone, any class in the same package, can see that as if it's public. Anyone outside that package cannot see what's inside. So let me just show you that. This is public, right? Public means anyone can see it. So mountain bike in here. Let me just create another bicycle. I'm just going to show you something. Bicycle equal new bicycle, and I'm going to provide it with just random things, 12, 13, 14. This is just for demonstration. Now if I do b dot, I would only see speed. Why? Because speed is public, gear is package private, and we are, as you can see, we are not in the same package, right? Demo is in default package, and bicycle is in this package. So you only see speed. You don't see the default, you don't see the private. Okay, let me just create the same thing and see if I'm in the same package. As you can see, we are in the same package, right? So if we are in the same package, I'm going to use that in anywhere, in here. Now, what would I see? I would still see gear. And speed. Gear because we are in the same package, right? So this is valid in the same package. It can be seen. Okay, so we have this. I showed you how we do toString. And for the overriding, for method overriding, you don't have to have the @override keyword. You don't have to have at override keyword. You can just remove it at the, and this is also would be good to go. Here it is. You would see no effect. It's just a notation that will tell the compiler I'm overriding a function. However, if I have override in here and I have different function name, then the compiler is going to say the method string of type modinBike must override or implement a supertype method. So that says you're not actually overriding something exists in the in the superclass. See that? If you're having that, then do you want to, this means you're creating a different function. If you're creating a different function, then do not tell the compiler that I'm overriding. I'm deleting that and the error is gone. See that? Okay, going back to our slides. We tested that, we have played with it like in here, and let me give you, and here is exactly what we have said. modinBike inherits everything, fields, methods from the bicycle, but adds the field seat height. So except with the constructor, it is as if you had written a new modinBike class entirely from the scratch with all the fields and methods from the bicycle. So, however, you didn't have to do all the work. You could have just done this. Extending bicycle takes over everything. You can use everything from bicycle, and you can actually use variables in bicycle to store values and methods in bicycle to set and get all these values and do functions on these values. Okay, so when to use public and protected, and what are those? What are those public protected? Let me show you something. We were playing with the default. Let me make something protected. I'm going to make this now protected. That was public. Now I'm making that protected. Protected. Just reminding you, when we had bicycle and we did this, we could have seen the speed, right? Right? Okay. Now I'm going to say protected, and protected makes a speed only seen in the children of bicycle. So if I'm going to say, for example, like system.print.println speed, I would see it. And actually, when you do speed, you would see speed with this yellow diamond, which makes it protected, which means protected. So you can use speed. Can I do that in here? Can I still see speed? Nope. Nope, I cannot see speed. I can see the function speed up, which is a public function. So what is protected? Protected only can see if a variable has the access modifier protected, it can only be seen in the children, like in mountain bikes or anyone extending bicycle, but not anywhere else. Okay? We are going to highlight those in the next few slides. So a subclass inherits all public and protected members, but you cannot inherit private. You cannot inherit private members. You can inherit default if you're in the same package. A subclass can inherit default if it's in the same package. You can use inherit members as is, replace them, hide them, or supplement them with a new members. I'm going to show you something we call hiding. Now, you know that I can have, for example, I'm going to create something. I'm calling that int x. Okay, int x. And now I have x in here. I can still use it in here. I can say x, right? and I can get access to it. And you can see it's x from bicycle. Now let me just do this, int x. Now can I still have access to x? Now yes you can, but this x is from mountain bike, which means I have hidden the x from bicycle by creating an x in the subclass. This is what that means. Okay, so the inherited fields can be used directly just like any other fields. You can declare a field in the subclass with the same name as the one in the superclass, thus hiding it, which what we have done a few seconds ago. And this is not recommended. Why would you use the same variable if you can use it in if you can use the variable from the superclass? Why? So it's not recommended. You can declare new fields in the subclass that are not in the superclass. So if you want x and y for a point, and you have a circle, why to create an x that would confuse you with the x from the coordinates, right? So the inherited methods can be used directly as they are. You can write new instance method. You can write new instance method in the subclass that has the same signature. A signature means this. This is the signature. This is the signature. The whole thing, the whole declaration is the signature. So if you have the same signature of a function from in the superclass and in the subclass, we call it function overridden. Overriding a function. Overriding a function. The subclass is overriding the function from the superclass. You can write a new static method in the subclass that has the same signature as the one in the superclass, thus hiding it. Now, function overriding is only if you're doing this. If you're doing a non-static function. If you do static function, it's still considered overriding. However, if you have the same function here, let's say I'm going to override a function here. I'm overriding this, so I'm copying the same exact thing in here. Let me just this was toString, and let me just remove this. So I can do that, thus I'm overriding. Usually if I'm overriding a function, it's because I want to change the implementation. So this is decrementing the speed in certain amount, and this is decrementing the speed, let's say, in double the amount of the argument, of the parameter. So I'm changing. This is why I actually need overriding. If I'm going to have the function again in the same with the same implementation, why bother having it? I actually inherited that from bicycle, so why having it? Doesn't make any sense, right? But if you have a static function, let's make this static. Which one? Decrement? Okay, let's make this static. And me just not doing anything inside. I'm just going to, so the speed has to be static to be used in here. But let me just get rid of this, and let me make this static. So as you can see, first this gives me an overriding error. Why? Because you're trying to override a static function by removing just the word static. So you should do static, and that works. But this function now hides this, and you cannot use it. Okay, so don't bother using static because mostly it's not going to be needed. You don't override a function with a static often, so it's rarely used. It's rarely used. Okay, so you can declare new methods in the subclass that are not in the superclass, like the thing we did in here. We had a set height. We can add public method. We are going to call it print. Okay, we can do that. Why not? You can write a subclass constructor that invokes the constructor of the superclass either implicitly or explicitly using the super keyword. And we have seen that in previous example. So a subclass does not inherit the private members of its parent class. However, if this subclass has public or protected methods for accessing its private fields, then you can use them in the subclass, and we have seen that. A nested class, something I'm going to explain to you briefly in the next few slides. I'm not going to include that in your tests. I'm not going to talk about it very much. It's just briefly introduction of nested classes so you know what are those. We are going to need them later when we work with local classes and all these things, but not in the same extent of what we are going to see right now. Okay, so nested class has access to all the private members of its enclosing class, both fields and methods. Therefore, public or protected nested class inherits by subclass has indirect access to all the private members of the superclass. I'm going to show you that in code once we do the nested classes. We have another keyword we are going to use. It's a final keyword. The final keyword, it's like a constant. It makes a variable constant. Now, if it's used with a variable, if I'm going to make, for example, like here, I'm going to create final int x, and I try to use x in here. Sorry. I wanted to, sorry, that has to be static to be used in main. Now, this is bold, which means it's a variable. And if you're defining a final, variable, you must give it an initialization value at this, at the definition statement. So I would say this is 4. Now I can print this, right? I can print x, and this is going to print x. I can access it, I can print it, but can I say x equals 6? No. As you can see, this is going to say no, it cannot be assigned because it's final. It's final. Okay, going back in here. So we can use final keywords with variables, methods, and classes. So what we're interested in mostly today is what makes a method if it's a final, and what makes a class if it's final. So during inheritance, we must declare a method with final keyword for which we require to follow the same implementation throughout all the derived classes. Let me just show you something in here. So here we have a method. Let me just call this final. SetGear is fine, right? Fine, no. Okay, let me just call this final. Right now, if you try to do this, let me just copy this because I'm going to try to override it. Let me show you what happens. Read the error. The error says you're trying to override a function with the final keyword, which means you cannot do that. You cannot override a function with the final keyword because, again, the overall benefit of the overriding is to change the implementation, right? To change the implementation, to provide different implementation. or to add to the implementation, or what I mean by that is extending the implementation, right? But wait a second. This says that you have to abide with the same implementation throughout the derived classes with the final keyword. So if we use the final keyword for the inheritance, that is, if we declare any method with the final keyword in the base class, the implementation is final and it's not going to be changed in the derived classes, and you cannot change it. We can declare a method with final keyword in any subclass for which we want the same thing. This subclass children, not to change the implementation of this method. So the final keyword also can be used with classes. And if you create a class and make it final, if you create a class like this, and make it final, then this class cannot be subclassed, which means this class cannot be extended. So when a class declared the final, then it cannot be subclassed. No other class can extend it. So here's a note: declaring class as final implicitly declares all the methods as final too. Overriding a method. We were talking about overriding a method. Now let's see the definition of overriding a method. The formal definition is, if you're doing a method overriding in object-oriented programming, this is a language feature that allows a subclass or child class to provide a specific implementation of a method that is already provided by one in its superclass. The implementation in the subclass replaces the implementation in the superclass by providing a method that has the same name, same parameters or signature, and the same return type. As I showed you, it has to be the same declaration. So here is declaring examples of declaring a variable, and the next slide I'm going to give you declaring a method as final. So if we have class parent and we have a final string variable PA, and we have a child parent. Now if you printed p.pa, p is a parent, p.pa, this prints hello, we are in the parent class variable. C.ch, this is printing this. Hello, we are in the child class variable. If you print C.pa, then this printed the same thing as this. Hello, we are in the parent class variable. Even though you're using C, right? Now we don't want that. We want to change it. We can say C.pa equal new text, but that will give you a big error. Why? Because you're trying to change a value of a final variable. You're trying to change a value in here of a final variable. This is error, right? You cannot do that. I just showed you that. So here's something with methods. Final methods. So if you have a final method, we are going to call that print. And we are going to create a function called print child. The print in the superclass says hello, we are in the parent class. The print child says hello, we are in the child class. So if you try to create, or actually override a method that is final by adding this in here exactly, then you will get an error, as I just showed you in mountain bike and bicycle, because you cannot override a final method. Okay, let's talk a little bit about nested classes. So in Java, it's possible to define a class within another class. It's like, remember nested loops? A loop inside a loop? Here, nested classes. A class inside a class. Such classes, the nested classes, they are known also as the inner classes. They are known also inner classes. So they enable you to logically group a class that are only used in one place. This place is going to be, for example, this place, right? So thus, this increases the encapsulation. And we are always looking for the encapsulation with the inheritance we are doing, with everything we are doing with objects. This is one of the main reasons we have object-oriented programming. And we can create more readable and maintainable code. So let me just take this and give you some examples. Let me just go to this slide, nested classes. Let me just copy this and put it in here. So in these three dots, instead of these three dots, I'm going to do int, not this, int x, and here do int y. And now let me just create methods to see which I can use. Now let me just read you something, then prove it with a code. Prove it with a code. So the scope of a nested class is bounded by the scope of its enclosing class, which means that if I can access the other class, then I can access the nested class. If the other class is private, then the inner class is not to be seen. So the nested class does not exist independently of the other class. So let me read you these. A nested class has access to the members, including private members of the class in which it's nested. So I'm going to prove to you that and prove the opposite of it. However, reverse is not true. The enclosing class does not have access to the members of the nested class. Let me just prove that to you. So I'm going to create two functions, inner function, and I'm going to call that inner function in the inner class. Let me just call it public, not public, just a function. Okay, even if it's a public, let me just call it void print. I'll try to print what? Let me just see if I can see x. Can I see x? System.out.println x. And that says yes, you can see x. What is that x? Let me just hover over this. It says it's the other class's x. It's the other class's x. Okay, I'm going to create the same thing outside of this, outside in here. Public void, let me just call it print, because you can have the same name because they are not related, right? They are not related. So let me just print y. I can print x, right? Because I'm in the same class. But let me just print y. Wait a second. What does that say? It says create local variable y. And let me just read the error. There it says y cannot be resolved to a variable. What does that mean? It means I cannot see y from the outer. So everything this inner class can see anything in here or in here as long as it's in the outer class range. But this other class cannot use anything from here. Cannot use anything from the inner class. This is exactly what we have said in here. So a nested class is also a member of its enclosing class. And we are going to see how we are going to define the nested class object and the other class object. So a nested class is also a member of its enclosing class. a member of its closing class and nested class can be declared private, public, protected, and even default. Nested classes are divided into two categories. Static nested class, I'm going to give you an example of the inner class. The static nested class, the nested classes that are declared static are called static nested classes. This is non-nested classes. So let me just show you how we are defining the objects. So if this is, for example, static, if this is static, then this function has to be static. And this has to be static for that to be resolved. And this is, we know that it's wrong. Now, if this is static, then the way you would define it is using this criteria. So outer class, here it is. But then the inner class, the static inner class, we're calling that inner class, calling that nested object, and equal outer class, then the inner class. So as you can see, this is simple. Why simple? Let me just explain to you why this is so simple. Because this is pretty much following the hierarchy, right? Outer class, then dot inner class. Remember we said this is a member of the outer class. So dot the member, creating the object of it, then new outer dot inner. New this. This is so simple. It's not simple, however, if you don't have a static inner class. Let me just put that to the previous edition. And let me just go and show you how this is being done. It's a little bit of a headache, I know. So this is going to be done like this. The outer class object, create an object of the outer class, like if you're creating any simple object. You have learned this in CS141. Then you see outer class dot inner class equal, and this is the strange part. You say the outer object dot new inner class. Dot new inner class. It's a weird way, but you have to memorize it. This is the way it's done. Okay. So let's talk about private members. We talked about public, protected, we mentioned default, but now let's talk about private methods. So if we have a private member method, remember that objects consist of a bunch of methods, right? So far, we use them public, we had some default, and why do I need a private method? I would need a private method because I would use the variables or the method inside the same class. Remember that if anything is private, like in here, remember that this is private cadence. I cannot see it anywhere but in bicycle, because it's private to bicycle, right? So if I'm having this weird private method, so private method, and I'm calling that set nothing, because I don't know what to set in there. If it's private, this is because I would need to use it inside any of these functions. But I actually don't have access to it in here. So if I have this function, I would say super dot. I don't have it. And if I would say set, I would have all the public functions. I would have public, protected, or default functions, right? but not the set nothing I just defined because it's private. I cannot use it in here. I can, however, use it in any of these functions. Set, you can use anything, and also use set nothing because it's in the same class, right? And it's in the same class. So why would we need private methods? I just said that. Let me just show you that in writing. If it's not intended for anyone else, making it private also helps hide the implementations, and this reduces the public interface, right? This reduces the public interface. We don't have to worry about the impact of changing a private method's signature because it's only affected inside the same class. It doesn't have to be, okay, if I have a public function, I'm overriding that in the subclass, then I decided to make it private in the superclass, then I have to go and remove it from the subclass, right? Or if I have overridden function in the subclass and I change something in the declaration, in the signature, in the superclass, then I have to go to the subclass and change it again with this all fuss, right? So I don't need to worry about it. If it's a function, if it's a private, then it could be seen inside the class it's defined in. Okay. Advantages of private methods. This promotes encapsulation. Again, we are using object-oriented programming and all its concepts because we want encapsulation. We always love encapsulation. This adds more layers of safety and security, right? Implementation hiding, which reducing the coupling. Coupling is the interdependency of objects on each other, classes on each other. Also, this promotes the modular code. Modular code is a code in which is separated into independent modules, and this modularity is not just about the code organization. You can read about it if you want to learn more. Limits the public interface, reducing dependencies. Limits the public interface, which also reducing the dependencies. As with the most practices, it's about trade-offs. Always it's about trade-offs. So if you have all your functions to be private, then what good is your object to anyone? Why do you have this object in the first place? Because no one can use any function in there, right? Because when you define an object of that class where you have all your functions to be private, then you cannot access any function or use any function. So what good it is? So we have access modifiers. We have public, protected, private. Now, the visibility of the public, you can see the public variable or a method in the same class, in the derived classes or outside classes, in any package, in anything, in anywhere in the whole world. Protected can be seen only in the same class and in derived classes. You cannot see it from other places. Now, protected, even if both classes are in different packages, it's the same. You can still see it in the derived classes. Private, however, you cannot see a private member, whether it's a function or a method, in anywhere but the same class it's defined in. So now this table shows you a clear idea of default, private, protected, and public variables or methods, visibility in the same class, same package but not subclass, and all these things. So if I were you, I would study and understand this table thoroughly. So now let's talk about something else. We are interested in composition as well. So you know that inheritance is the is-a relationship, right? The is-a relationship. And composition is the has a relationship or uses a relationship. So this allows a class 1 to use another class 1 without taking over the interface, without taking on the interface of class 2. So again, the interface, I mean all the functions or services the class provides. So here's a composition example. Here is a composition example. In a checkers game, you have functions is the start game, or if the game is finished. To check if the game is finished. Now the checker game is using a GUI, using a graphical user interface, or has a graphical user interface. Has a consists of many game pieces or uses game pieces, and it has a board and so on, right? So through composition, a powerful class can be built from smaller classes that can be built and tested separately. Those classes could be built and tested separately. So composition is achieved by using instance variables that refers to other objects. This just means that we have member variables of the type of our new class. It's similar to when you use the string. Remember, a string is an object. It's not a primitive data type. So you have that string in your class. You use that string. Doesn't mean that your class is a string. No, you use a string in your class. So this lets us let's use that class and its functionality. And this is what's called has a relationship. It's like when you say engine is a member variable of a car. So the car is using an engine or has an engine to run, but not a car is the engine. A car is wheels. No. So why do people favor composition over inheritance? So composition over inheritance, or sometimes it's called composite reuse principle in object-oriented programming, is the principle that classes should achieve polymorphic, and in a few minutes we are going to talk about polymorphism. Polymorphic behavior and could reuse and code reuse by composition, containing other classes that implement the desired functionality, instead of through inheritance being a subclass. Let me give you a famous example. I know that a student is a person, but also I know that a teacher is a person. Now the teacher has a job, right? Has a job. And the job that has inside a salary and a role and teaching courses and blah blah blah, all these things. Now if I say a teacher is a person and has a job, that means I'm using both inheritance with the is a relationship and composition with the has a relationship. Is a person, has a job. So here it is. A person has a job. So job is going to be an entirely different class with role, salary, ID, and all these things. And a person is going to has a job. So the way I would use it, I would define in here my job variable, but then instantiate it whenever I have a person. If I'm talking that all persons in the whole world have jobs. And I can use the functionality of that job. of that job, whether it's inside a constructor or where I define the job, or outside the constructor in any other function, because I defined the job or declared the variable outside. Okay, so let me just give you a little bit of more wide range examples. So if I have a job in here, and I have person, but in my system now, not every person has a job, because I have students in my system, and this student does not have a job. Like a student has a student number, a student has a major, and gets the name from a person, because every person has a name. But if I have instructor, a teacher, the teacher has a job. And when I instantiate a teacher, I set that job, and I can use the role and the salary of that teacher in the job that are defined in the job class in here. So here's the job class, put it in here. Then instructor is going to use this class, and could set the salary, could set rule if from that job. Use those. You can either override. It's not overriding right now. It's like you're writing two identical functions in here. Two identical functions. Because if it's overriding, then I can use salary in here, but I cannot. Can you use salary? No, you cannot. So this is not function overriding. You can try this. You can try this method. You can try this example, and I'm going to ask you to do a wider example in modules. Something similar to this system, to the graduate interface inheritance, using composition, using having a person, a student, undergrad. I'm going to ask you that on modules when you're done with the whole lecture. So composition versus inheritance, the idea of view, you can argue that you can say a circle is a point, and I'm extending the point by adding radius. Or you can say a circle uses a point, because you can think of a circle as a tiny points that would make a circle. Now, with inheritance in here, the child is taking on the interface of the parent. It uses everything from, basically it's like you recoded the whole thing in circle, right? But with the circle composition, circle point composition, circle can use the things in point, not taking over those things. And here's the sub-summary of this lecture. Composition versus inheritance. Composition, one class uses another. Inheritance, one class taking on the other. So the third concept today is, third main concept today is polymorphism. Polymorphism means, poly means many, morphism means changes or behaviors. So in object-oriented programming, polymorphism refers to a programming language ability or feature to process objects differently depending on their data type or or classes. More specifically, it's the ability to redefine methods for derived classes. I'm going to give you an example of that. So we know that a cow and pig, they both are animals. They both make sounds, but the cow moves and the pig oinks, right? The sound of the pig is oink, and the sound of the cow is moo. Now, I can have animal class. And let me just try this with you. I'm going to create animal classes and all these things. And I'm going to use all these classes in one file. I'm going to show you how to use these classes or multiple classes in one file. Let me just go copy and paste this to save some time. So we are copying and pasting this. So I'm going to copy this. I'm going to copy this public class animal. And now you're saying, oh, what is this? So that says public type animal must be defined on its own file. So I have to rename this to be animal. Or I can just remove the public. If you have a class that is not public, then it doesn't have to have the same name as the class name, the file name. So I can have as many classes I want. So here is my demo. This is the one that I'm going to be working on. So let me just put that back in here. Then I have one big. So let me just format that. Now you can do format things from source format or Ctrl+Shift+F. That makes it a little bit nicer. So I can have this, then I can have cow. Now if you want to create classes, you can create a new class like this. Create a new class. I'm not doing that. I'm just showing you how to. You can do a class. Then when you say what class you want, you can say that inherits from what. You can start typing animal, and this is going to show you animal in here. Animal in the default package, which is talking about this one. I'm not going to do that. I'm going to have the classes below each other. So I'm going to copy this, put it in here. Again, do the formatting and remove the public, because again, if I make any class public, then it has to be in the same in a file with the same name. So I'm removing that. Now, as you can see in here, animal has string name and hunger level. You can set those two in a constructor. You can get the name, get the hunger level, and make sound. Now this animal is going to make sound. This animal is going to make sound, and this is going to make a default sound. This is going to make a default sound, right? A default sound. And if we called that, we can override that in here. We can override and make sound. And now cow will say, what's up, dog? Right? Cow would say, what's up, dog? And this is where we have another class. It's called lion. And let's do the formatting. Now lion is going also to override make sound that says lion says make sound. And let me just take this as my kind of demo, and let me just format this. So if I printed this, if I ran this and I have to rerun it because I changed the main class. So that says cow says what's up, doc, because cow, here it is, cow. Let me just call that Sally. And the lion is Leo. Okay, and this is the hunger level. So that will still say cow and lion, but wait a second. What is the main type of cow? What is the main type of lion? Animal. animal. So basically you can call cow and lion using their outer class or using their parent name. So animal cow equal new cow, Sally. Animal lion equal new lion. Now when you call make sound, that is going to call this. That is going to call this make sound, right? The one from animal. If you use it with only animal. Now cow is going directly to the one in here, in cow. So that goes to the cow and calls make sound in here. That goes to the lion. Where's lion? And calls this make sound. That says lion, right? This is going to call make sound. Is going to call the make sound of where is it? Not here. Okay, this one. Name plus says what's up, dog. Name plus says what's up, dog. And this is called animal. I named it animal with animal, and that called this one. So basically, polymorphism is having two or more children called using their or defined using their parent class name. Also, I can show you something where we actually need it. If I'm going to call animal, and this animal is going to be an array of, and I'll call it that animals equal. I'm going to have what in there? I'm going to have new cow, and this cow is named Sally 2, and the hunger level is 0. And I'm also going to have new lion with Leo 2 and 12. Now what I have is I'm going to write a for each animal and animals. I'm going to call that A. For each animal A in animals, I'm going to print. I'm going to call make sound. So A dot make sound. Let's see what that is going to print. Let me just separate those. Not separating those. Print some hashtags. Okay. Now this is going to say cow says what's up, doc. Lion says what's up, doc. Now why is that? Because I know they both are animals, so they can be in an array of animals, right? But then when you call even though A is of type animal, but A.make sound is going to call make sound of each of those, right? Make sound of each of those. Now, if you want to call the make sound of animal, this is animal, then you have to cast it. But the thing is, when you try to cast it, this is going to say, okay, wait a second, this is not going to call animals make sound. Then how would I cast it? I would make it like this. Now I casted A, I cannot. What I was doing in here, why that was wrong? Because you were trying to cast the method. No, what we need to do is cast the variable. We cast variables, not methods. Now let's see. That was printing cow and lions, right? That is now going to print cow, lion, says what's up, duck, right? Cow, lion, says what's up, duck. Because that was using name. Okay, so with method overriding, here is how you override the method. And method overriding is basically replacing a method inherited from the parent. Placing a method inherited from the parent. So we have a lot of methods overridden from object. And we use many of them during our work in Java. So if we need a method to do something different than what it actually does, what we have it doing from object, we override that method and make it changes to suit our purpose of what it needs to be doing. For example, we have seen how we overridden the toString function. The toString function returns a string representation of the object. Now, in general, as I showed you before, the toString method returns the string that is textually representing this object. The result should be a concise but informative representation that is easy for a person to read. So it's usually recommended that all subclasses overrides this method. The toString method gives you a string representation of the name of the class where the object is coming from, and the @ character, and then the unsigned hexadecimal representation of the hash code of the object, as I said before, in this format. And that returns the string representation of the object. So if you want to represent any object as a string with the toString function, you can do that. This is going to return to you a string representation of the object, as I said. Now, if you printed any object, the Java compiler internally invokes the string object. This is why when we first printed the object name in the example I showed you previously, that was giving us the string representation of the object class at the hexadecimal of the hash code. But then when we overridden the toString, it showed the bicycle, cadence, and all these things, right? So overriding toString function, what you need to do is just to override it, or in Eclipse, simply you can go to source, then choose override toString. Or you can just provide the implementation of public string toString, and you can do whatever you want inside, as long as you return a string as you promised. Now, as I said, you can do that in Eclipse easily with generating toString from source menu, and you can set what what fields to be included, what inherited fields if you're doing inheritance, and this is going to generate a toString function for you that overrides the object's toString. Now, this is a toString overridden in mountain bike class. So as I said before, the @overrides is critical if a critical annotation that informs the compiler that you're actually overriding an element declared or a function declared in a superclass. However, be careful when you use it, because if you have @override in the subclass for a function that does not exist in the superclass, then the compiler is going to give you a hard time and give you an error. Now, another function we are always interested in rewriting or overriding is the equals method. The equals method compares two objects for equality and returns the true. If they are equal, returns false if they are not. Now, this is using the equal. And for primitive data type, that works because comparing 5 to 3, that would work, right? And if we say, is 5 equal to 3, then you would say no. And if, for example, if 5 in X and this is in Y, that will work. But for objects, it does not work. It actually goes to see if they're both variables, both objects, are pointing at the same object encapsulated in the heap. So, book var1, book var2, if we use the basic equals method, this returns true. This returns true. If we use book var1 with book var3, using the equals method, the basic equals method, without overriding the one in object with the correct overriding instructions, this returns false. So this is not what we want. Because as you can see, for example, book title 1 is actually stored in book variable 3. So book variable 3 and book variable 4, they should say that they're equal. The equal function should return true, but actually returns false. Why? Because it does a shallow comparison. A shallow comparison is when it goes to see if the address where this is stored and the address where this is stored are equal. This is shallow comparison. What we should do is a deep comparison. A deep comparison, we should actually compare the relevant data members. So, I'm going to show you how to actually, instead of doing this shallow comparison, how to actually mean both objects are equal or not in terms of the data members, not where they are stored. So, for example, the index of an array list is returning the index of the first occurrence of the specified element in the list, or -1, based on the equal function, equal method of that object. So if you do not override the object's equal function, then the index of is going to use the default object equal. Now, when I say object equal, I mean the equal coming from the object class that you haven't overridden. So this can, instead of doing all this, looking for a book and see if the ISBN is equal to the ISBN and so on, you can override the equal function in your book class, and you can do that. That will return to you the index of the book you're trying to look for. And that follows this. By going to the equals in your class and looking for each data, for each element in the array, and check if it's equal to the thing you're passing. So the steps to override equals: 1, to check if the object is compared with itself, then return true. If I'm comparing two objects in the same memory location, then definitely they are the same. If object is an instance of the current class or not, then I have to do different things. If they are not in the same class, like I'm comparing book to a student, then I definitely need to stop the comparison and say false. I return false. Then I typecast the object to the current class so that we can compare data members. If they are actually in the same, both are objects of the same class, then I need to start comparing the data members. So let's see how we can do that. I'm overriding the equal in my class. My class name is test, and what I provide is object. What I provide is object. Then I say if this equal object, if the object I'm comparing is the current object I'm using, then return true. Return true, because I'm comparing the same object in the stack. So this is object 1, object 2, and they have the same address for the object in the heap. Or I have them in different cells in here and in here, and this is object 1 and this is object 2, and both are pointing to the same thing. Then I can say yes. Then I can say if object equal null, if I'm passing empty object that is not actually defined yet, it's just declared object, or the object classes like comparing test to student or comparing book to student, right? The object class is not the current class name, like test to book. Then I return false. If it's null or class names are not the same, then return null. Then I say, okay, I'm making this object, I'm casting this object to my object, because if it's return true, if it's the same object, if it's not of the same class, then I return false. Then the next logical thing is that it's of the same class and it's not this current object I'm comparing with, right? Then I start comparing the data. Comparing the data is, okay, return if num equal num. Comparing each of the data, right? This one and this one. If it's num equal to this num. And data equal the data, or the data is null and data equal this dot data. Because I may be interested in the number, because the number is unique. This is how it's done. Now to override equals, I'm going to show you how to do that on Eclipse. So let's say I'm going to bicycle, and in bicycle here I'm going to generate equals. So you can override implement methods, and I would use equals. Now equals is added in here. Now this equal is going to give you, as you can see, this equal give you the general, the basic equality check. What you need to do is to follow things in here. Those are the steps you have to follow. Those are the same in the summary. Okay, so the overall summary of our lecture today is composition, one class uses another. Inheritance, one class takes on another. Polymorphism, programming feature that allows you to process different objects differently depending on their data type or class. Method overriding, you replace the implementation of the function in the subclass so saying that differently, you provide different implementation to the function you defined in the superclass in the subclass. And that is concluding our lecture today.